Now, we saw this happen once yesterday, I think, in the lesson we were doing together, and it was a little bit in the homework, but they were simple ones. The ones today are a bit harder. So we did see this a little bit, but I wanted to talk about it a bit more directly and go over a couple of examples. Equations have to be in the proper form before we can factor and before we can solve. So whether we're factoring or solving, this is the same thing. Our equations have to be in the proper form. Proper form looks like this: ax squared plus bx plus c. And if it's an equation, it would be equal 0. Or ax squared plus bx, where a and b can be anything. Any integers. We don't want decimals or fractions there for sure. Equals 0. Or x squared minus c equals 0. So these three are in the proper form. Here are some examples of things that are not in proper form. Ax squared equals bx. No good. We need to do some work on that before we can factor it, before we can finish solving it. Ax squared plus bx equals c. Still no good, right? It's got to be equal to 0. Specific example of this might be something like that. People think it looks like you can divide both sides, but you cannot. You have to get everything on the left and set it equal to 0. Another specific example that we're going to look at today, 3x plus 7 squared plus 6x plus 10 equals 0 or something like that. Like brackets in there are not going to work. We got to do something about brackets before we can solve. There's one exception. When you have something like this, x squared equals 9. We looked at an example of this yesterday. That's the only kind that can be solved two ways. What would I do? Every other kind everything needs to come to the left, equal to 0, and you get rid of brackets and you get rid of fractions. You do all that to put it in the right form is what I'm saying, so that you can factor it, so that you can solve it. This is the one kind where we have another method that we can do a question like this. What would I do with this one? What could I do? So if I take the square root of both sides, I get x equals plus minus the square root of 9, x equals plus minus 3. If 9 wasn't a perfect square, I mean, you could still take the square root of it. It would just be a decimal. And depending on what you're doing, that might be fine or that might not. It depends, totally depends on the question. Okay. The other way that this one might look, just as a reminder, is like this, right? And you would factor it as a difference of squares. So you could always set equal to 0 and factor, but this is the one exception where it doesn't have to be brought to the right form. But you still got to know how to do it. Like there still might be some work to do to be able to solve that. Any questions about that before we move on? I hope this helps people get on the right track. Good? All right, let's try a couple. So we're solving by factoring. I've hinted at this before. There is another way that we can solve quadratic equations. Some of you probably prefer the other way. We will learn about it next week. But when the question says solve the equation by factoring, you can't use the other way. You have to factor. And then in general, the other way is usually slower, especially if you're good at factoring. Factoring is way faster. Sometimes when we use the other way, we get decimals when we don't need to. So like there's other reasons why we like factoring. Okay. What do I have to do for question A? What has to be my first step before I can solve? Because like I'm solving by factoring, but this is my point. That's not factorable. So we got to get rid of the brackets. We're going to have to put everything on one side, collect all like terms, figure out what we have left. We might have a question like this one, right? We might have a question like this one, trinomial. The top one's a trinomial. The second one is a common factor question, or we might have a difference of squares type question. So who knows what we're going to get when we're done? We'll find out. So I go 2 times x and 2 times 3, which is 2x squared plus 6x. You probably don't need my help doing this, so you go ahead and continue, and you can just check your answer along the way. Five times 3 and 5 times x. We saw questions like this yesterday where we just bump everything to one side. So we've seen this before, but remember I'm going to do minus 5x and minus 5x. And I'm going to do minus 15, and then on the other side, minus 15, and there isn't anything on the other side, so I have just the 15. 2x squared. 6x minus 5x is x. And 0, nothing minus 15 is just negative 15. And I've gotten rid of everything on the right side, so that's equal to 0. Sometimes people they think they've gotten rid of everything, so they don't need to write the other side anymore. They don't do equal 0, they just leave it blank or something. But remember, we're solving an equation. You always have to have a left side and a right side. So we had a little bit of work to do, a couple of steps before we could even factor, and then it's right back to the factoring idea of what type of factoring is this? What am I looking at? Starting to observe things like how many terms it has, what do the terms look like, that sort of thing. So this one to me, trinomial, of course, and it has a leading coefficient of 2 on the x squared term, so it's complex trinomial. So go ahead and try to factor that. Okay, so I got this. I got 2 times 3 is 6. 1 times 5 is 5. And I want it, and it's going to be 6 minus 5 to give me 1. So the 5 has to be negative. I get my brackets, and then remember, therefore, 2x minus 5 is 0, and x plus 3 is 0. 2x equals 5. Divide both sides by 2. X is 5 over 2. Bring the 3 over. X is negative 3. Yes? I think you should write this step, and then you can skip to the end. You don't have to do 2 steps, at least for now. And then after we've practiced this a few more days, you might be fine to go straight to that. Jada?
I forgot to put the signs earlier on in the question, but I still got the same answers.
Yeah, you would. So did you have a negative 2x squared here? Oh, I can come and look at what you did after. That's interesting. Usually if some of the signs are the same and some are different, then you're going to get yourself mixed up. And I would say sometimes when you're solving these, what if I had a negative 2x squared? We don't usually factor with a negative out front of that term. So I would change that and make it positive and flip the signs of everything else, right? So if this could be negative 2x squared minus x plus 15, that's a lot harder to factor because we're not used to it. So in that case, I would flip the signs. I'll have to look and see what you did and see if. Okay, let's try one more. What's different about B? Sarah? It's got fractions. Do we know how to factor with fractions? It's possible. It's a lot harder. It would be the same kind of thing, but trust me, you don't want to do that. So the best thing that we can do here is get rid of the fractions. How can I get rid of the fractions? The nice thing is because this is an equation and I've got a 0 on the other side, it's relatively easy to do. I multiply through by something that will get rid of the fractions. So something that's a common multiple of all the denominators. What's a common multiple of 3 and 2? 6. So I'm going to make a little note to myself off the side here. I'm going to multiply by 6. And I'm going to show this step. 6 times x squared over 3 minus 6 times x over 2 minus 6 times 3 over 2 and 6 times 0. Don't forget we're doing that. It's not going to change the right side. It's still going to be 0, but don't forget we are doing that. Whatever you do to one side, you have to do the same to the other side. So if there was a number over there, like a 1, I'd have to multiply it by 6. Then I'd have to bring it over, right? So watch for that. And then I can do this trick. 6 divided by 3 is 2. 6 divided by 2 is 3. 6 divided by 2 is 3. And I end up with numbers that I'm multiplying by. So this is going to be 2x squared minus 3x, 3 times x, and 3 times 3 minus 9. 6 times 0 is 0. Now I have a complex trinomial again. Go ahead and try to factor and solve that. Okay, so I factored it. 2x plus 3 times x minus 3. And I got negative 3 over 2 and positive 3. What do you think? All right. I want you to try this one. Remember what we said? I actually gave an example of one just like this, that it can't be solved the way it is. You got to do one tiny little step for it. But this one, what we're going to add to is we're going to do a check. Okay, so I'm going to let you try to solve this one, and then we will do the check together. It's so funny how this is, like I said this yesterday, this is often one of the trickiest ones for people. Because I get to this, and it looks like this. And what you might remember is if it doesn't have the like +5 at the end, right? It doesn't have the third term. Everything has an x in it, common factor, every time. That's what this type is. It's a common factor type. Okay, and I got 0 and 2. Be careful when you get down here. I still have two things. This is my A and this is my B. A times B equals 0. A is 0 or B is 0. So either 6x is 0, divide both sides by 6, and x is 0. Sometimes that's supposed to be really easy, but again, sometimes we just blank or just screw it, like a little mistake, and we're not thinking, and we say that's something else. But it's 0 and 2. Okay, and now we're going to do a check. What do I have to check? I have to check both solutions. The check is a little bit annoying, I guess, because it's just extra work. Like you got to do it twice. So I'm going to check x equals 0 first. How do we do a formal check? Left side, 6x squared. Right side, 12x. Sub 0 in on both sides. 0 squared, 0. 6 times 0, 0. 12 times 0, 0. And then we have to make our conclusion statement. Then I have to check the other one. So 2 squared is 4. 6 times 4 is 24. 12 times 2 is 24. We've done that this year. Hopefully we remember doing that. But make sure you get the form right for that, and make sure you realize that I have two solutions. I got to check them both. Remember we said with quadratics, you could have 2 solutions or 1 solution or no solutions. In the homework, there were some that had only 1 solution. We haven't really seen any that have no solutions yet. All right, I want you to give that one a try, and you can try the check as well. And we can see that it's not in the right form. So I've got to clean everything up first. Okay, just take a look. So the solution's up there. I haven't done the check yet. Be careful that you expand properly. If you don't expand properly, there's a really good chance you're going to get something that can't be solved, which is tricky, right? And so make sure you do the expansion properly. Be careful. Watch your x's, watch your exponents, that kind of thing. And here's my check. And why don't you just watch for a minute? I like that you write out the left side and the right side as the actual equation with the variable first. But I'll only make you do that once. For the next one, you don't have to do that. And then show the substitution step. So this is 3 times negative 4. And because sometimes we have brackets, it's a bit tricky how you write it. So that one would look like that. And this one would look like 2 bracket. And I would need another bracket. 4 squared minus 4. Then it's a bedmass question, right? Not too hard, but there's a little bit of work here. 3 times negative 4 is negative 12. Negative 4 times positive 2 is negative 2. Negative 12 times negative 2 is positive 24. And over here, I've got 2. Negative 4 all squared is 16. 16 minus 4 is 12. 2 times 12 is 24. Okay, I'll let you try the other one if you haven't got there yet. That one's right so far. I'll do the next check, and then you've got your practice to try a few on your own.